Okay, call all your friends that are in grade 8 that are preparing for maths paper 2. Call all of them. Call all of them. They need to come here to this live right now. Your grade 8 maths paper 2 friends, call them. I'm going through this paper right now. Call them. Say they must come ASAP. Double tap on the screen, like the lives. Call all your grade 8 maths paper 2 friends. All your grade 8 maths paper 2. 8 maths paper 2. Just 8. I don't want anyone else. Please guys, don't pressure me into anyone else. Don't pressure me into doing any other live. I'm going to be doing grade 8 maths paper 2. So go and share with your friends that are in grade 8. They need to be here. Alright? Share the live, share it, and share more of it. Okay, grade 8 maths paper 2, guys. For those who are in grade 9 who want to, who are preparing for GEC, as usual, tomorrow morning at 5 a.m. GEC grade 9. We are continuing on where I left off. We are going to be doing this 2023 together with that 2024. We'll be going through that there tomorrow morning at 5 a.m. We started this morning. The live that I did this morning, the video is already up. It's on my YouTube channel, the video that I did. So tomorrow morning, guys, grade 9s will be looking at this, okay, tomorrow morning. But for now we are doing grade 8 maths paper 2. So all those who are in grade 8, please double tap on the screen, share with the live with many people that you can, and invite people to come. They must come. They must be here. All right. There are the instructions. This is November 2024. So please, guys, many of you are saying that this and that and this and that. This, guys, is just for practicing and preparing you for tomorrow, grade 8 maths paper 2. Okay, yeah, grade 8 maths paper 2. Let's turn over the page and let's see what we have here. Okay, first question. Choose the letter from column B that best describes the term in column A. Alright, guys, grade 9 GEC will be doing tomorrow, guys, tomorrow morning at 5 a.m. and then during the day as well we'll do some grade 9, but today I have to focus on the grade 8's paper 2, so please bear with me there. Choose the letter from column B that best describes the term in column A. 1.1 rectangle. The distance measured around a 2D shaped. Is that referring to a rectangle? No. A triangle of which all sides are equal. The angles formed when two straight lines cross each other. A closed 2D shape that has two equal adjacent short sides, two equal adjacent longer sides, and two opposite angles that are equal. Doesn't seem like it. A triangle with base angles equal. No. Angles on either side of a set of parallel lines? No. A closed 2D shape that has the opposite sides equal and parallel and the internal angles equal to 90 degrees. Seems like that resonates with rectangle. It's G. So yes, guys, you are correct. It is G. So we write the answer there in the space provided. 1.1, a rectangle is not D. D is a kite, a closed 2D shape. Quando, you are right. A closed 2D shape that has two equal adjacent short sides, that basically refers to a kite. Okay, let's move here. 1.2. Well, 1.2, now we can see it lines up or squares up with this, a closed 2D shape that has two equal adjacent short sides and two equal adjacent longer sides and two opposite angles that are equal. That is definitely a kite. So we are going to write D in the space provided there. Okay, 1.3. Perimeter. What is perimeter, guys? We know that perimeter is the distance around a shape, whatever it is. So 1.3, perimeter, definitely the distance measured around a 2D shape. You guys are correct if you are saying it's a 100% correct. So 1.3 is A. 1.4. Vertically opposite. What is vertically opposite? Okay, is it angles on either side of a set of parallel lines? No. A triangle with base angles equal? No. Angles formed when two straight lines cross each other? Oh yeah, here we go. Vertically opposite has to do with angles formed when two straight lines cross each other. We call two straight lines here cross each other, this angle and that angle, we call them vertically opposite angles. Okay, so vertically opposite has to do with angles formed when two straight lines cross each other. That is C. So we write 1.4 as C. And lastly, equilateral triangle. Guys, what is equilateral triangle? Equilateral triangle, okay, I see in the comment section E. Let's see E. A triangle with base angles equal. No, it's not E. It's not E. Equilateral. Equilateral, remember the word equi means equal, and then lateral means sides. So equal sides, okay, has to do with equal sides. A triangle with equal sides. So which one, which letter best fits a triangle with equal sides? Definitely a triangle of which all sides are equal is an equilateral triangle. So this is what? B. Guys, there's no reason why these marks, let's say the question paper tomorrow was like this, there's no reason why we shouldn't get these marks. All right, please guys, make sure you understand your terminology for geometry so that you can be able to get the marks. Okay, let us know what these things are. What if we had been asked to find a term for when angles on either side of a set of parallel lines, angles on either side of a set of parallel lines? You see, we need to know all these terms. Okay, so let's know them. Let's move on. Next question. Study the following and in each case simply circle the correct response. If DE is parallel to FG, all right, there is D is parallel to FG, we have 120 degrees here, we have X. The question is, then the value of X is it X is equal to 30, X is equal to 160, X is equal to 70, or X is equal to 120? So is it A, B, C, or D? All right, and I see in the comment section those who are commenting, if this is 120, what is the value of X? Right, so most of us are saying D. Okay, please guys, it definitely is D. Why? Because why would you say it's D, guys? What relationship does 120 and X have? What is the relationship? We call these angles what? A flamingo. That's good, happy for you. All right, this is the 2024 November question paper from one of the districts or the regions in the country. Yes guys, this is corresponding angles, definitely. Okay, definitely corresponding angles. Let's not forget that. It's like an F, as Caden says. Big man, you are correct, it's corresponding angles. So that's why we would definitely circle D. X is equal to 120 degrees. Let's move on to the next one. We'll do grade 9 guys on Wednesday definitely, but we'll also be doing grade 9 tomorrow morning. Grade 9 GEC will be doing tomorrow morning. Okay, 2.2. Triangle DF is not drawn to scale. Which statement is true for triangle DEF? Okay, is it A, a scalene triangle? B, it is a right angle triangle. 5 a.m. guys. In grade 9 I do 5 a.m. Okay, do it 5 a.m. It is a right angle triangle. C, is it an isosceles triangle? Or D, is it an obtuse angle triangle? Okay, yes, remember guys, I post all my lessons on the YouTube channel. The link is in my bio, so if you miss something here, you can always catch it on my YouTube channel. Definitely you'll find it there. The link is in my bio. It's called Maths is a Game. You can always check it out there. So A guys, is this a scalene triangle Okay, we have 13 centimeters, we've got 8 centimeters, we've got 5 centimeters. The sides of this triangle are not the same. So if you have unequal sides, that means it's a scalene. Scalene triangle has sides that are not what? That are not equal. We have 13, this is 5, this is 8. So it's definitely a scalene. It's not a right angle, it is not an isosceles, and it is not an obtuse triangle. It is a scalene triangle, so it is A, definitely A. Let's move on. 2.3. The complement of 23 degrees would be, what does the word complement means? It means that angle that we will what? That we would add to 23 degrees so that it gives us a total of what? Of 90 degrees. So that angle we add to 23, that will give us 90. That's what we call the complement. So we are asking us, what is that angle? All right, that we will add to 23, that will give us 90. Because remember, these two complements are what give us complementary angles, because complementary angles are angles that add up to 90 degrees. So the complement of 23, is it A, 23, B, 67, C, 77, or D, 157? Definitely is what? It's B, guys. 67. The angle we add to 23 degrees, that is what we call a complement. Okay, let's move on to 2.4. If lines A, B, and CD are parallel, the co-interior angles are what? Are they supplementary A? Meaning, do they add up to 180? Because that's what supplementary means. B, are they complementary? Meaning, do they add up to 90 degrees? C, are they equal? Or D, are they less than 90 degrees? Okay, so majority of you guys are saying the answer is what? It's A. Yes, guys, it definitely is A. Complementary angles. Remember, guys, in our letter shape, where we want to see the relationship between angles that lie on a parallel line, we have these three relationships. Top, those two angles are equal for the F shape. Bottom, those two angles are equal for the F shape. We call these angles corresponding angles, and we always say that they are equal as long as we have lines that are parallel. Then we have the U shape. This angle and that angle, their sum adds up to 180. The U shape angles, co-interior angles, and as long as the lines are parallel, we say that these co-interior angles add up to 180 degrees. All right, then the N shape or the Z shape, we call these alternate angles as long as they are lines that are parallel. Okay, so here, guys, we are saying if lines A, B, and C, D are parallel, the co-interior angles, so co-interior angles has to do with the position of the angles for our U shape. Okay, the position of the angles in the U shape. So if lines are then parallel, what do we say about those co-interior angles? We say that the angles are supplementary. In other words, they add up to 180. So it is A, guys. Okay, it's not B, it's not C, and it definitely is not D. Okay, so I hope that is clear for all of us. Okay, let's look at this one. The radius of a circle with diameter 12 centimeters is... Okay, the radius of a circle with a diameter of 12 centimeters is... The radius of a circle with diameter 12 centimeters is... Guys, do you know what a diameter is? A diameter is a line that extends from one end or circumference of the circle through what we call the center to the other end of the circumference. That is what a diameter is. It cuts the circle into half. Then half of the diameter from the circumference to the center, we call that the radius. Okay, so if the diameter is 12 and we know that the radius is half the diameter, what then is the radius of the circle? Is it A 144 centimeters, B 75,41, C is it 24, or D is it 6? Definitely the answer is what? D. You guys have said it correctly. It's D indeed. It's 6 centimeters because the diameter, right, is twice the radius, and the radius is half the diameter. Okay guys, that multiple choice, we went through it like it was nothing. And really and truly, when the marks are there, guys, we should make sure that we get all the marks, the maximum marks that are possible. Let's move on. Determine with reasons the values of angle X and angle Y in each of the following diagrams. So we are going to determine the angle X here, this angle. And we need to do what? Give reasons, all right, for when we write down our particular statement. So what do we see here? We see a line AB and we see the line BC. What is in there? We see this box here. What does the box stand for? This is what we call a right angle. In other words, angle X, 16 and 36 all add up to what? To 90 degrees, because this is a right angle. In other words, AB is perpendicular to BC. This is a right angle, and these individual angles here, from here to the angle X, that X, 16 and 36 all add up to 90. So what do? We write down 36 degrees plus 16 degrees plus X is equal to what? 90 degrees. What is the reason? The reason is complementary angles. Why do we say complementary angles? Remember, what did we say complementary angles are, guys? Complementary angles are angles that add up to 90 degrees. Does that make sense? Then we write our reason, complementary angles. Then we solve for X. We should by now know how to solve for X. So X we isolate on the left. 36 and 16 are angles on the left. So what do? We transpose the angles. 16, when it crosses over the equal sign, becomes negative 16. 36, which is positive, becomes negative 36 on the other side. Then what is our answer? X is equal to what? What's 90 minus 16 minus 36 in the comment section, guys? What is the answer that you get as your angle for X? 90 minus 16 minus 36. I see 38. One person is saying 38 degrees. What do the rest of you say? 38. Mr. Stop Calling Me says 38. Ike says 38. Stylish says 44. Brett says 38. Siastro says 38. Majority of you are saying 38. So I believe the majority, hopefully the majority is not misleading us. All right. 16 minus 16 minus 36 does give us negative what? Negative 52. So 90 minus 52 does give us definitely 38 degrees. So those who said 38 degrees are 100% correct. I've confirmed it using my calculator mind. So do we get the 3 marks? Most definitely. How do we get the 3 marks? Our statement gets 1 mark. Our reason, complementary angles, gets another mark, and then our answer, 38 degrees, after simplifying and solving for X, gets the 3rd mark. So we get full marks there. Not a problem. So let's always remember, guys, that this here is 90 degrees. It means right angle, and these individual angles, because they complete this 90 degrees, from here to there is X. That's a portion of the 90. From here to there completes 16 degrees. That's a portion of the 90. From here to there completes 36 degrees. That's a portion of the 90. All three of these add up to the 90. That's why we say 36 plus 16 plus x is equal to 90 degrees, and we say complementary angles. Then we simply solve the value of x, and it's as simple as that. Adjacent complementary angles is also fine, Mahiro. To say that as well is 100% fine. To say complementary angles is 100% fine. Whether you say adjacent complementary angles, because adjacent means angles next to each other, these are next to each other, shared by this common vertex, and they add up to 90, that's fine. To say complementary angles or adjacent complementary is good. Then you solve for x and you get your answer. Let's move on to the next one, guys. Here, what do we have? DEF. Given that DEF is a what? Is a straight line. That's what we are told. Determine the value of x. Give reasons for all your statements. So this is DEF. This here we are told is a straight line. So what do we know then? This box means what? 90 degrees, right angle, right? This x is the angle next to this 90, and this x here is also next to 42 degrees. These three angles, 90, x, and 42 degrees, they are adjacent to each other. They share this common vertex, which is E, and they lie on a straight line. So what then can we state about these three angles? We can say 90 degrees for the box, that's from here to there, plus x, that's from here to there, plus 42 degrees, that's from here to there. From here all the way to there, we complete the straight line. These angles are adjacent or next to each other. We can add them together. They are equal to what? 180 degrees. Why? Because these are angles that are on a straight line. So we can write angles on a STR line as our reason. That statement is 100% correct. This reason is 100% correct. What are we left now to do? To solve for x. What does that mean? We isolate x on the left, and then we take all the other terms. There are 2 additional terms separated from x by a plus sign. So we take this 90 that is positive, we transpose it to the other side, it becomes negative 90. We take the plus 42 degrees, we transpose it, it becomes negative 42 degrees. Then we subtract 180 minus 90 minus 42. That means x is equal to what, guys? I'm sure you guys have seen it in the comment section. Many of you have actually said the answer that's correct. 180 minus 90 minus 42 degrees gives us a beautiful answer of what? 48 degrees. And Dukes, Luvian, Baby Marsha, Carboy, you guys are simply phenomenal. Lilonge Kubega, you are simply phenomenal. You guys are doing amazing stuff. It is not 38. It's not 38, guys. It is 48. Let us not have misconception. It is very sad when we get the answer incorrect simply because we do not know addition and subtraction, which is a basic concept learned in earlier grades, guys. Let's not make such a mistake. A viewer avoid such. Mjingo Longozi, thank you so much, Lingozi, and yeah, all the rest. You guys are doing phenomenal. Let's move on. Thank you so much for the gifts. Those that actually, I saw that rows fly through there. Really appreciate it. 3.1.3. Ooh, nice one. Look at this. What is this, guys? This is AB. This is DC. These two lines, they are what, guys? AB is what to DC. And why do we know that? These arrows here indicate that AB is what to DC. Yes, Siastro the artist, Cloney, and Abraham, Benjamin, SS Milo. They are parallel, these lines. AB is parallel to DC. Then, what do you see here? this angle, which is y plus 20 degrees. What do you see here? This angle, which is y plus 8 degrees. What relationship do these two angles have? Yes, special ZA. These two angles are between parallel lines and we refer to them as co-interior angles. Yes, Lotin Kwake, very good. Buddy Cooper, see Astro the artist, Mfundo Beats, you've got the beats there, I see. So these two angles have a relationship of what? Co-interior angles. It's our U-shaped relationship. Between parallel lines, what did you say these angles actually do when added together? They are add up to 180 degrees. Guys, it's like your armpits. It's like your armpits. Imagine that these are your arms, and then this is where your armpits are. This is where it stinks a lot. Like these two angles are like where your armpits stink. What do you do when your armpits stink? You add roll-on. You add deodorant. Why? So that you can make the situation better. So it's like these angles, we add them together to get 180. We add roll-on, we add deodorant so that we can make the situation a bit better. So we add these two angles, your U-shape, your armpits, it stinks. You put deodorant roll-on so that you can make the situation better. So what do we do with the two angles? We add them together, guys. Makes the situation solvable. Y plus 20. Y plus 8, we add them together. We know they are equal to what? 180 degrees. What's the reason? Now, guys, please listen up. When you write your reason, don't simply write co-interior angles and be happy that that is the case. No, don't do that. Okay? What you need to also include is your lines that are parallel. With your reason, include the lines that are parallel. AB is parallel to DC. That's what makes your reason have power. If you write co-interior angles alone, your reason doesn't have power. Look at this, guys. This is what we call the acceptable reason document for Euclidean geometry. It's in the exam guidelines for grade 10. So you guys are future grade 10 pure maths learners. And when you write your reasons, look at this. If AB is parallel to CD, then the co-interior angles, we say that they are supplementary. Look at the reason. You must write co-interior angles and you must include parallel lines. That goes for corresponding angles as well. That goes for alternate angles as well, because these are the other relationships that you find between what? Parallel lines. I beg you guys to not forget to write parallel lines. Okay? Please. So there, you see, we are following the guidelines. Then we add like terms, guys. Y plus y, that gives us 2y on the left. 20 and 8 give us 28. So what we do is we take that 28, we transpose it as positive as it is. And then we get minus 28 on the right-hand side. Then we solve for what? For y. So 2y is equal to what's 180 minus 28? You can just use your calculator, get your answer, 180 minus 28. Yes, we get 152. Thank you so much, you beautiful people. This is 152 degrees, guys. Very important. Then from this point, it's not 162, guys. It's 152. Be careful, these people that keep on getting these funny answers. Then here, the 2y and the 152 degrees. To find the value of y, 2 is multiplied to y. So what do? We divide both sides by the coefficient. 2 is the coefficient of y, so we divide by it. Yes, Evalerato. We divide by 2, Evalerato. We divide by 2. We divide by 2, not by 2y. We divide by 2 both sides. Then 2 and the 2 cancel. In other words, 2 divided by 2 gives us 1, and then the y is there. So then y is equal to what? 76 degrees. It's as simple as that. And we are happy, we are smiling. The answer is ours. We get all full marks. Statement, reason is 100% correct. Our simplification is 100% correct. And our answer is very much delicious and wonderful. Thank you so much, Miyageni, for the donut. I really appreciate it. Wow. Appreciate the donutness, guys, and I appreciate the likes. Thank you so much for the likes. Thank you for the commentary. Thank you for the participation. You guys are beautiful. It's like you're gonna smack the test tomorrow. 3.1.4. Okay, It's like we are on fire today, like nobody's business. Study the diagram below and answer the questions that follow. Study the diagram below. Can I get the exam guide? I'll do that lot in Kwaki. I will post it up for all of you so that you can see. Okay, those people who are wanting to do maths in grade 10 next year, guys, it's so important to know those exam guidelines for geometry. You know, it makes life so easy, and when you have mastered them and you write the reasons the way that they are asked, you'll be a happy man. You'll be a happy man. Study the diagram below and answer the questions that follow. So let's see here. We've got MN. Okay, we've got PQ. We've got in MN, we've got this is a parallel line, and PQ is also a parallel line. T is there. Okay, now the questions that they are asking here is name two angles whose sum is equal to the size of angle S4. Name two what? Angles whose sum is equal to what? To the size of what? Of angle S4. Where's angle S4? Here is angle S4. And what do they want? Two angles whose what? Whose sum is equal to the what? To the size of angle S4. Which are the two angles whose sum will give us angle S4? Which are those two angles whose sum will give us angle S4? So we want two angles. What does sum mean? Sum means the addition of two angles. There are two angles here in this diagram who, if we add together, will give us angle S4. So because we have parallel lines, we need to look at this. Okay, this is a parallel line. This is S. This is angle S1, angle S2, angle S3, angle S4. This is T. This is angle T3, angle T2, angle T1. All right, I hope that makes sense. Now all they want is the two angles who, if we add together, will be equal to S4. So if you look at this angle here, look at this angle here. Do you see this angle here? This is a transversal line. It cuts this parallel line, and obviously with this parallel line creates this angle here. Okay, so angle T1 and angle T2 has a relationship with angle S4. What is that relationship, guys? Angle T1 and T2 together equal to angle S4. What is the reason for that? Yes, guys, it is corresponding angles. So we are asked here to name the two angles whose sum, meaning the addition of whatever those two angles is, will be equal to angle S4. So what are those angles? It's angle T1 and angle T2. The sum of angle T1 and angle T2 gives me the angle S4. Why, guys? Because here we see the F-shape relationship. F, I'm sure you can see, on top of this parallel line, on this side of the transversal line, on top of the other parallel line, these two angles are actually equal. So we say angle T1 plus angle T2 gives us angle S4. Are we together, guys? Angle T1 plus angle T2 is this angle on top of this parallel line on this side of the transversal line, and angle S4 is the angle on top of this parallel line on the same side of this line, okay, which is TS. So angle S4 is equal to angle T1 plus T2. Those are the two angles, guys. The two angles whose sum is equal to the size of angle S4. Those are the ones, okay? So that's all they wanted. Okay, angle T1 and angle T2. Now determine with reasons the size of the following angles. Angle S1. Angle S1. Guys, what is the size of angle S1? What is the size of angle S1? Luvian says 58. Vert op angles. Very good, Luvian. Luvian, you are amazing. Caden says 58. Mafungwacha says 58. Eva Lerato says so. Caden as well. Michelle. Right, we've got a lot of people that are saying 58. Remember, we need to provide a reason for the size. So if I go back to my document here, guys, once again, if you go down to my beautiful, amazing document, vertically opposite angles are what? Are equal. So their vert op angles equal. This is an acceptable reason according to the document. So yes, I'm going to say angle S1. I can see S1 has a relationship with angle S3. Those are angles that are vertically opposite. Remember, we said X, this angle is equal to this angle. If you have two lines that are crossing each other like this, we say that this angle is equal to that one. Those are vertically opposite angles. We say that this angle is equal to that one. These are vertically opposite angle. Thank you so much for the rose dynamic. I really appreciate it. So this angle is equal to that one is equal to that one. So here we can see this 58 degrees. This line is intersecting that one. So angle S3 is equal to angle S1. So that's why we say angle S1 is equal to what? 58 degrees, because this 58 degrees is the angle that angle S3 is, and it is equal to angle S1. What's the reason? Vert op angles equal, and I'm taking that from the acceptable reason document that I spoke about. Okay, no, we say vert op angles equal. That is the reason that we write down. The whole intersecting lines obviously is something that we understand is the relationship between the two angles when we have intersecting lines. So intersecting lines actually give rise to the relationship of vertically opposite angles. Okay, all right, this would be vertically opposite, but angle S1 and S4 would be angles on a straight line. You see, so you must always see the relationships that are there. S4 and S1 together add up to 180, but angle S1 and S3, those are vertically opposite angles. Let's go down here. What's angle T3? Now, where is T3? Here is T3. Angle T3. Here is angle T3. What relationship does T3 have with anyone else? Well, there's a few things we can see. Remember, if we find that angle S1 is 58, we can update our diagram and write 58 degrees there. So now, if you are looking at T3 now, having updated your diagram, depending on who you are, you can either see what. Okay, remember S3 was equal to S1. Why did we say that? Vertically opposite angle. That's why we said that. Now we have this 58 degrees. It is angle S1. We want angle T3. Angle T3 has a relationship with who, guys? Angle T3 has a relationship with angle S3. Thank you, Luasta. Angle T3 has a relationship with angle S3. Those who can see the relationship between angle S3 and T3, what is that relationship called between these parallel lines? We call this the on top, on the same side of the transversal line. This is on top, and we refer to the relationship as corresponding, the F-shape relationship. T3 and S3 have a corresponding relationship. So you could say angle T3 is equal to 58 degrees and write your reason as corresp angles. But don't forget to do what, guys? This is not complete as a reason until we do what? Until we state the lines that are parallel. MN is parallel to who? PQ. So we must write MN is parallel to PQ. If we don't write parallel lines, it becomes a problem. Thank you, Lasta, for the rose. MN is parallel to PQ. So that's one way of getting the angle T3. Or someone else who's looking at this diagram, having gotten angle S3 from the previous response, angle S1, sorry. Remember, you said S1 is 58. Now you look at S1 and you're like, Haibo, S1 and T3 give me the Z effect, or the Z shape, or the N shape, if you want to call it that. So what relationship exists between S1 and T3? Okay, if you are looking at it in another way, what is the relationship between S1 and T3? The Z shape. Yes, guys, it is alternative. The alternate angles. The Z-shape relationship gives me alternate angles. So I can say here, angle T3 is equal to 58 degrees for another reason, different from the one that I had stated, depending on who is looking at the diagram. You could say alt angles instead. Don't forget to state the lines that are parallel. We don't say alternate angles equal. We say alt angles, then which lines are parallel? MN is parallel to PQ. You state the lines that are parallel. Guys, your reason is incomplete if you don't state lines that are parallel. Okay, so it's up to you. Now we can go and update the 58 degrees there. That T3 is 58. Now, they are asking us to find the value of X. They want us to find the value of X. And remember, we have 2X here. We have 90 there. We have 58 there. There's a relationship that exists between these 1, 2, 3 angles. You could find X using these 3 angles in this way that I have explained. Or you could look at these 58 and look at these 2 angles. There's a relationship that exists between 58, 90, and 2X here for these parallel lines. Are we together, guys? 2 ways of looking at this. I repeat, you could look at T3, 90, and 2X. These 3 angles, they share a common vertex. They lie on a straight line. So what do we know about them? These are angles on a straight line. What do we know about angles on a straight line? If they share a common vertex and they complete a straight line, it means when we add them together, we get 180. So we can solve for X in that way. For that reason, angles on a straight line. Or if you are someone else, you are looking at this diagram, you can see that this here is my U shape, my armpit angles, where it stinks. This angle and this angle, this is where it stinks, my armpit angles. The roll-on needs to be applied unless we want to have everyone run away from us. The roll-on needs to be applied. There has to be addition of roll-on or addition of deodorant. We add the 2 angles together for our U shape. All right, the armpit angles. So that means 2X plus 90 plus 58 would be said to equal to 180. What would be the reason if I am looking at the diagram, looking at this 58 and this angle? Co-interior angles. MN is parallel to PQ, and then I would solve for X. So those are 2 different ways of answering the same question, and you would still get the very same answer. So depends who is looking at the problem. Depends who is looking at the problem. So you go ahead and use your angles on a straight line, you will get that answer. I will use co-interior angles. I'm going to also get the answer. So 58, when I say 2X plus 90 plus 58 is equal to 180 degrees. Now, if I decide to use co-interior angles and then state my lines that are parallel, MN is parallel to PQ, then I am 100% correct as well, and I can solve for X here. 2X is equal to, I isolate the X term, take the 90, becomes minus 90, take the 58, becomes minus 58, and then solve for X. So 2X is equal to, what's 180 minus 90? It's 90. What's 90 minus 58? That gives me 32 degrees. Then what do I do here? I divide both sides by the coefficient of X, which is 2, What I do on the left, I do on the right. I get x is equal to 16 degrees. So you guys, I got 16 a long time ago. You were 100% correct. Remember, Juice, if you wanted to, you could use angles on a straight line. It's just that I decided to look at the diagram from this 58 that I got, which is for S1, and this 2x plus 90, which gives me co-interior. I still get the same answer. If you had decided to use 2x plus 90 plus 58 angles on a straight line, you would have also been 100% correct. So it doesn't matter. I'm just doing this to show you that geometry has a level of flexibility when you do it, because as long as you know the reason you are using, you can always be able to get the correct answer. Okay, someone else is saying, or corresponding. Of course, if you would go ahead and use corresponding, it would mean that you would have to find angle S4, then take S4 and say it's equal to these two angles. Then after that, solve for x. So it's a bit longer, but it would still also get you to the answer. Remember, guys, we don't want to spend too much time answering a question. We do want to actually spend the least amount of time using the least amount of energy, so that we can be able to, at the end, check our work after finishing and completing the paper. Let's turn over the page. Determine the size of the angle y in each of the following. Okay. The size of angle y. So we have 66, we have 46, we have y, and what is this, guys? Okay, what is this? It is a triangle. Are we together? It's a triangle. What do we know about the sum of angles in a triangle? You guys are 100% correct. Definitely. The sum of angles in a triangle, we know it adds up to 180 degrees. So what do we do here? We simply take all these angles there. Start with y plus 66 plus 46 is equal to 180. Then what do we do? Look at my document. I come back to my document. Look at this. The interior angles of a triangle are supplementary. So there are three reasons I could use for your own information. You could write either angle sum in triangle, or you could write sum of angles in a triangle, or you could write int angles triangle. You choose any one of these three that is acceptable as a reason to be used. So we just write the one that is more sweet for us. Okay, so please don't judge me. I'm deciding to use int angles triangle. You can use that reason, any one of those three that I showed you, that should be fine. Then y is equal to, you transpose everything else, 180 minus 46 degrees minus 66 degrees, right? Then y is equal to what? What's 180 minus 46 minus 66? Let's see my gym monkeys there. What are they saying, my gym monkeys? Okay, 68 degrees seems to be the consensus. Okay, 68 degrees, 68 degrees, 68 degrees. No, guys, I'm having no people request, sorry. Okay, let's come here, 4.2. People are saying 68, so I wrote 68. If it's wrong, it's wrong. If it's right, it's right. Okay, I see people saying 74, and that's where you know that, you know, if people are making mistakes and things like that, that's a problem. Okay, look at this one. What type of triangle is this? It's a equilateral triangle. Thank you so much. Someone said equilateral triangle. Okay, equilateral triangle. So since this is equilateral, this side, and this side, that means all three sides are equal. What do we know about the angles of an equilateral triangle? What about the individual angles of an equilateral triangle? What do we know about them? The individual angles of the equilateral triangle, individually, these are the same, and they are 60, 60, 60. So what I can do here, I can say y plus 30 degrees, this y plus 30 will be equal to 60 degrees. That's one way of doing this. You can say y plus 30 is equal to 60 degrees. Reason? Okay. You can write equilateral triangle, right? Which is fine. Then when you solve for y, what happens? Y is equal to 30 degrees. It's as simple as that. Okay. Or to do this question another way, you could obviously write down all three angles. If this is y plus 30, that means that is also y plus 30. You could say that is also y plus 30. Okay. Someone is asking, why am I saying y plus 30 is equal to 60? Remember, guys, that each individual angle of an equilateral triangle, this is 60, this angle is 60, and that entire angle is 60 degrees. Okay, 60, 60, 60, because the sides, all three sides are equal and the individual angles are all 60 degrees. So what check out 60, 60, I like that, I love that, 888, check out 60, 60. So basically you take this unknown y plus 30 and equate it to 60, which is an individual angle of the triangle. Then you can solve for y. Okay, that's one way of doing it. Or if you're someone else, you could say y plus 30. This is also going to be y plus 30. And this is also going to be y plus 30. Okay. There's no need for alternate angles. This is not alternate angles, guys. These are angles of a triangle. There's nothing about alternate angles here. Okay. Please just be careful there. You are reading into the wrong thing. Okay. Okay. So I can say y plus 30 plus y plus 30 plus y plus 30 is equal to 180. This is another way of doing the very same question. And then here I will say the sum of angles in a triangle, or interior angles of a triangle, or angle sum in triangle. Okay, remember the y plus 30 means that angle E is in terms of y. You are given the angle not as a number only, but in terms of y. So it is a variable with a number. Remember, this is an expression. You are in grade 8. You've learned about algebraic expressions. So angle E is given in terms of y. Y plus 30. All right. So that means if it's an equilateral triangle, each individual angle in terms of y will be y plus 30. That's what it means. Then you can take the individual angles in terms of y and do what? Add them together and say they are equal to 180 and give a reason. Then you solve for y. Y plus y plus y will give you 3y. Okay. 30 plus 30 plus 30 will give you 90, right? Then you transpose the constant degree, which is 90, to the other side. So it's 180 minus 90. Then you isolate 3y. Then you divide both sides. The coefficient of y is 3. You divide both sides by 3. Y is equal to 30 degrees. This is another way of getting the very same answer, just approaching it in a different way. Okay, I hope that makes sense. And I hope that's clear. Okay, so please, guys, it's so important to use this ingenuity. So let's go to the next question. You will welcome Bula. In the sketch below, PQ is parallel to RT. Angle, now please take note of this, angle ORS. Let's go there. Angle ORS. Remember, when they have this, it's the middle letter that signifies the angle. So the symbolism here is angle ORS. The middle letter defines the angle. So let's move. ORS. So they mean this angle. That's what they mean, that angle. Angle ORS and angle SOR. Let's move. SOR. So they mean the middle letter, this angle. They are saying angle ORS and angle SOR are what? Are equal. They are equal. This angle and that angle are equal. That's what we are told. Now they are saying furthermore, use the information provided in the sketch to determine the values of A and B in the following sketch. We need to determine the values of A and B in the following sketch. Now, from what we've been told that PQ is parallel to RT. So we know that these two lines, they are parallel. Remember, between parallel lines, there's a lot of relationships that come about. Now, this here, angle ORS and angle SOR are equal. In other words, this angle and that angle are equal. So I can say angle ORS is equal to angle SOR, and they are both equal to who? To A. So if that is A, that means that is also A. What is the reason? Angles opposite equal sides. Angles opposite equal sides. I want to show you something. If you go down to triangles, your statements for triangles, the angles opposite the equal sides in an isosceles triangle are equal. If ever you find yourself having to use this statement to justify something that you are writing because you see an isosceles triangle and you want to say the angles that are opposite the equal sides in that isosceles triangle are equal, this is your reason. Angles opposite. Now, instead of writing down equal as a word, I've written equal as a sign, as a symbol. Angles opposite equal sides. Guys, we use this reason, not isosceles triangle and not base angles of an isosceles triangle. This is the reason that we use angles opposite equal sides. So I'm coming back to what I said earlier on. I said angle ORS, meaning this angle, and angle SOR, meaning that angle. They are what? They are equal. I'm already told that angle ORS is A, so that therefore means that angle so I'm already told that angle SOR is A, so therefore I'm saying now angle ORS is also equal to A, because we are told that those two angles are equal. They are equal to AY, angles opposite equal sides. So then I can update my diagram and write A there. Now, to determine A, I will simply use my understanding of this simple fact. These two angles together are what I call my interior opposite angles. You learned that if you have a triangle and there is an angle that is external to the triangle, and the side of this triangle is extended by a line in the same line of the side of the triangle, the angle formed externally, we say it is equal to the sum of the two interior opposite angles. So if we add angle A plus angle B, it should give us angle what? Angle C1. But the key here is that the angle external or exterior must be formed by a side of the triangle, all right, which goes in line with the extension. The extension should be in the same line as the side. That's what makes it a true exterior angle. So our exterior angle is equal to the sum of the two interior opposite angles. So whenever we use this, we write exterior angle triangle. I'm going to come back to this here again, this document. Exterior angle of triangle. The exterior angle of a triangle is equal to the sum of the interior opposite angles. I repeat, the exterior angle of a triangle is equal to the sum of the interior opposite angles. So guys, it is that angle and that one that face this inside angle, but outside is the exterior. So it's not this angle and that one that is equal to this, the sum. No, it's not this one and that one. It is this one and that one. The interior opposite angles, the sum of them is equal to the exterior. So if you come here to this diagram, 86 degrees is our exterior angle. Is it truly the exterior angle? Yes, it is, because RS, the side of the triangle, is continued to T in the same straight line. So this is a true exterior angle. I repeat, RS is the side of the triangle continued to T in the same straight line. So this is an exterior angle indeed. So we can say that A plus A, this A and this A, is equal to 86 degrees. That 86 degrees. What's the reason? Exterior angle of triangle, written from the acceptable reason document. Then I can solve for who? For A. What's A plus A? Addition of like terms. We keep the base A. We add the coefficient 1 plus 1, which gives us 2. So this is 2A. Then we have 86 degrees that side. We then do what, guys? Divide both sides by the coefficient of A, which is 2. What does that give us? A is equal to 43 degrees, as many of you have been saying all along. So I can update my diagram. Every time you get something, guys, you update, update, update. What does updating do? It helps you to be able to know what you have in the diagram, so that when you want to answer other things, you can then look at what you have and utilize the information that is there to then answer the rest of the questions. Updating your app helps you to be able to utilize the new features on your app. When you update things, guys, you update the use of your phone. It helps you to be able to use your phone more swiftly. So we update things all the time. So we must, when we get answers for our diagram, update our diagram so that it now features having the new things that we just got. So now that I have 43 and 43 there, how then can I find B? Now, whoever is looking here is looking at this and like, look at my Z. Look at my Z. Look at it. Look at my Z. Parallel lines, we have alternate. This angle, this entire angle is equal to this angle, Z shape. All right? And B is there. That's the only thing I don't know. Since I updated this 43 degrees, makes life very easy. So you could say B plus 43 is equal to 86 and solve for B. Or someone else was looking at this diagram like, oh, look at this, Z. This angle is equal to that one. Okay? There's also a Z here. And this Z is kind of straightforward. Since we have 43 degrees, it means B, we can just get B is equal to, we can just simply say B is equal to 43 degrees if we use this approach. Do you see that, guys? You can just say, if we look at this Z, we can simply say B is equal to 43 degrees. Our reason? Alt angles. What do we make sure we don't forget, guys, when we write our reason? Stating the parallel lines. PQ is parallel to RT. That is B. Done and finished. Or you could go the Z that is here. B plus 43 is equal to 86 degrees. Reason? Alt angles. PQ is parallel to RT. You solve for B, you'll still get the same answer, that is 43 degrees. Please, guys, when you write alternate angles, do not forget to state the lines that are parallel. I repeat, that's what makes your reason powerful. Okay, That's what makes your reason powerful. Guys, I'm going to turn over the page to the next question because I've found A, I've found B. I deserve my 7 marks. I'm smiling all the way to the mark bank. 7 distinction is coming. Distinctions galore. I love it. I love it. I love it. I love it. Okay. Love it, love it, love it. Because distinctions is just my thing. 95% and above for mathematics is just one of those things that I definitely love and enjoy, and getting that is not really a problem for me at any given day, any given time. Okay, let's turn over our attention to this now. In triangle DEF, angle E is 90. This is grade 8. DF is square root of 8 centimeters. That's DF. EF is square root of 5 centimeters. There is EF. Determine the length of DE. Where's DE? Here is DE. Show all your working out. Leave your answer in third form. You're welcome, Faf. Welcome. Determine the length of DE. Where is DE? There is DE. What is this, guys? And what do they mean when they say third form? Guys, third form is simply leaving your answer as a irrational number. In other words, if you look at square root of 8, this is third form. Okay? The square root, when your answer is written in root form, that's what third form means. So square root of 8, the answer here, this DF is in third form. EF is in third form. They didn't write it as a decimal number, but they wrote it as a root. Okay? So what do we use in a right angle triangle to find a missing side? Okay? We use what, guys? Surely we know we use Pythagoras. Mr. Pythagoras. Mr. Pythagoras is crying for our attention. What does Pythagoras say? Pythagoras says, and I will show you in this acceptable reason document, Pythagoras simply says the following. In a right angle triangle, the what? The square of the hypotenuse. What? What is this? Who is Mr. Hypotenuse? Hippopotamus? No. Hypotenuse. The square of the hypotenuse is equal, they are saying, to the sum of the squares of the other two sides. Okay, so Luvian is helping us out there in the comment section. It is saying that the square, the hypotenuse, is the longest side of the right angle triangle. 100% correct, Luvian. Thank you so much, Ava, for the rose. Really appreciate it. In a right angle triangle, the square of the hypotenuse, the square of the hypotenuse is equal to the sum of the squares of the other two sides. And whenever we use this, guys, don't forget to write our reason as Pythagoras, or we can write theorem of Pythagoras. Okay, so let's come here. Where is our hypotenuse? Guys, the hypotenuse side is always opposite 90 degrees. So we call this side the hypotenuse. So I've given you a clue. The hypotenuse side is always opposite the 90 degrees. So this is 90. Opposite 90 is what we call the hypotenuse side. So that means DF is the hypotenuse. For grade 8, DF is the hypotenuse. Immortal, we are not doing grade 11 work. This is grade 8, so we don't know that yet. What we know is Pythagoras. We use the hypotenuse. So the Pythagoras theorem is saying the square of the hypotenuse. So what do? Let us square the hypotenuse, which is what? DF squared. The square of the hypotenuse side is equal, Pythagoras is saying, to the sum. Sum means plus. The sum of what? The sum of the square of the other two sides. So what are the other two sides besides the hypotenuse? It is DE, so we square DE, and EF, so we square EF and add those two together, because the sum of the square of the other two sides is equal to the hypotenuse side that is squared. Don't forget to write our reason. Our reason is Pythagoras. Then we substitute the values that we have. DF, the square root of 8. But remember, we square that square root of 8. DE, we want DE, but we keep it in square for now. EF, we substitute EF. It is the square root of 5, but we square it. Determine the length of DE. So that means we need to isolate DE. DE needs to be alone on one side. So that means we're going to take the square root of 5 squared to the left hand side. The square root of 8 squared minus the square root of 5 squared is equal to what? DE squared. All right. Now, if we apply the square root, the square to the square root, that means we are going to get 8 here. If we apply the square root of 5 squared to the square root of 5, then it means we are going to get 5. Okay. And then here, DE is what we are looking for, guys. So that means DE still retains the square. What is 8 minus 5, guys? It is 3. That means DE squared is equal to 3. After doing so, what do we do? What do we do? We get rid of the square by squaring DE. But remember, in an equation, what we do on the left, we must do on the right. What we do on the right, we do on the left. Then that means DE is equal to the square root of 3. Okay. Centimeters. Okay, so DE is equal to the square root of 3 centimeters. That's as simple as you would have it. DE is equal to the square root of 3 centimeters. Because remember, they said that leave your answer in surd form. This here, guys, remember I said when you have a square root retained in your answer, that's what we mean by surd form. Okay, so surd form means that it doesn't mean anything else but just that. Surd form means you leave your answer with the square root. Okay, yeah, you leave your answer with the square root. You don't put this in your calculator and get the decimal form of the answer. You leave your answer having the square root. That's what surd form means. Surd form simply means you leave your answer having a square root. Okay, so that's how we get that. Guys, the reason why I wrote this statement as you see it, because I see some of you saying you should have written DE squared is equal to DF squared minus EF squared. Remember, this statement is written on the basis of the theorem of Pythagoras from its definition. Pythagoras says the square of the hypotenuse side. What is the hypotenuse? The hypotenuse is the side that is opposite the 90-degree angle. Okay, the hypotenuse is the side opposite the 90-degree angle. So I took the square of the hypotenuse side, and Pythagoras says the square of the hypotenuse side is equal to the sum. Here is the sum. Sum means plus of the square of the other two sides. The square of the other two sides, DE is one side, DE squared, EF is the other side, plus EF squared. And then you write Pythagoras. Okay, and then from there you simplify, you are able to get to the answer. Okay, So you DE, you isolate, you transpose the square root of 5 squared here to the other side. You simplify 8 minus 5, you get 3, you take the square root on both sides, you get DE is equal to the square root of 3. So that means the answer is the square root of 3 centimeters. And that's the answer in set form. Had they said to you, round off your answer, leave it to 1 decimal place, then you would go ahead in your calculator, you would actually punch in SD and then get your answer in, rounded off to that decimal place that they want. Okay. Next, consider this quadrilateral A, B, C, D below. Okay, so this paper was out of 60, this one that I have before you, 1 hour 30 minutes. Okay, it was 2024, as I said, guys. Okay, 2024 paper. I'm doing a past paper here, so please consider the quadrilateral A, B, C, D. Here it is, right? They are saying calculate the length of B. Where is B? Here is B. Guys, it's important that you do this. You first look at the diagram and then you ask yourself, they're saying calculate the length of B. Then you have to ask yourself, where is B? And you're like, here is B. Then when you look at this diagram, what do you have? So even though this is a quadrilateral, a four-sided shape, what is it made up of? It's made up of triangle ABD, which is a right angle triangle, and it's made up of triangle CDB, which is also a right angle triangle. But now what do you see? You can't exactly use this right angle triangle yet. Why? Because it has this side length, we don't have this one. Okay, you do not have enough information for this right angle triangle to use Pythagoras in order to find B. You don't have enough information yet. Thank you so much, Spare, for the hot me. So what we then do is we leave this triangle for now. We go to this triangle. Okay, so triangle ABD has side AD given to me and side AB given to me, and I can find side A using triangle ABD. Two sides, guys, given, and one side that I don't know gives me the opportunity to use Pythagoras to find the missing side. Now, what is this missing side in triangle ABD? What do we call this side? Okay, this is 90 degrees. Opposite the 90 degrees, we have side DB. What do we call this side in a right angle triangle? Do you guys still remember? We call this the hypotenuse. Thank you so much, guys. I love this. It is called the hypotenuse. In triangle ABD, we refer to this side as the hypotenuse. So since this is the hypotenuse, remember what the theorem of Pythagoras says? It says the square of the hypotenuse side. So let's go right and say in triangle. So my teachers know, okay, I'm working in triangle ABD. That's where my focus is on. The square of the hypotenuse side. In other words, A squared is equal to what? The sum. What sum? Of the square of these other two sides. What are these other two sides? That is 5 centimeters squared. So I'm just going to write 5 squared. And AB, which is 12 centimeters squared. I'm just going to write 12 squared. Then I'm going to write my reason, because it's very important. Pythagoras. So let's go. A squared is equal to, what's 5 squared? 25. What is 12 squared? 144. What's 25 plus 144? 169. Now I don't want A squared, I want A. So what do I do, guys, if I want A? All right, the square we need to get rid. So we apply the what? The square root to the square. But remember, What we do on one side, we have to do on the other. So what do? We take the square root on the other side. Okay, then final answer. Since a, the side that we have there, is a length, it means that our answer is equal to 13. But 13 what? Remember guys, these units, the sides are in centimeters. So that means this is a 13 centimeters. So that means I can update my diagram now, just like how would I update my iPhone or update any phone that I have. Update anything, you update, all right? Update the information. Now we have DB. Now we have DC. For this triangle DBC. So we can go ahead now and say in triangle DBC. Now you are showing your sir or your ma'am at school that, look, sir or ma'am, in triangle ABD, this is what I got. I've updated my information. Now, sir or ma'am, I want to show you that I know my stuff. I am now moving on to this triangle that I wanted to move on to even from the beginning. It's just that I didn't have enough information. Now I have the information. I have the information. DB I have, DC I have. I want B. What is B? That's what you ask. What is B in triangle DBC? Remember, B is opposite your 90 degrees. What do we call this side, guys? What is this side? Yeah, so once again, we know that that side is the, for triangle DBC, it's the hypotenuse. So then we can say B squared. We can say B squared. The square of the hypotenuse side is equal to the sum of the what? Of the square. So I'm going to say 84 squared plus 13 squared and write my reason. Don't forget to write Pythagoras as your reason, guys. Don't forget. People forget to write Pythagoras as a reason and then they butcher things up. 84 squared, guys, what is that? Okay, I don't know what 84 squared is from the top of my head, so I'm going to need you genius people in the calculator comment section to really give me what 84 squared. Thank you so much, Charlene. Charlene, you are amazing. Okay, then 13 squared, 169. Charlene just made my night there with that quick response there. Okay, 7,056 plus 169, guys. What does that give us? That a big, beautiful, round, sweet answer that has 7 at the beginning. That is, thank you, Louvian. You can see Louvian is like that kid at school that always answers questions, you know. Louvian and Charlene, they like, you know, sit up top of the class, and Ava, Leo, you know, these guys sit up top of the class and they always answering questions. And some kids, they get like, oh, this guy is always answering questions. Anyways, so when 7,225, we take the square root to get rid of the square. Then B is equal to, what is the square root of 7,225? Leo tabs, thank you so much, guys. It's amazing. It's 85. 85 what? Don't forget the unit, centimeters. And there we have it. They wanted us to get the value of B. Calculate the length of B. We had to first get A. There was no other way. We could not get B in any other way but pass through getting A. We move from the place of most information to the place of least information. The place of most, because when we have information, it gives us the opportunity to investigate and find and solve. But if we go to a place where there's no information, it's very hard. It's like if a detective is busy trying to piece together pieces of evidence, a detective needs to go to the place where there is information, someone that can give him hardcore evidence and facts, so that the investigation can continue. Then you can move from a place of most information to the place of least information and solve the case. Okay, I mean, it goes with anything, guys. Just life in itself is like that. Look at this question. The diagram consists of two congruent triangles. So these guys have already concluded that the two triangles are congruent. Guys, the minute they say that triangles are congruent, what does congruency mean? What does the word congruent mean? The word congruent means same shape, same size, exactly the same. It's like identical, exactly the same, guys. Okay, I see this person who keeps on saying, can you do perimeter area, can do perimeter area. Can you just wait, please? All right, I see your comment, and you typing it over and over again is not gonna make me do perimeter and area or not. So I see your comment. Thank you for commenting. Can you just wait a bit? Let's just wait and see with the completion of this paper, okay? The diagram consists of two congruent triangles. So we are told there are two congruent, meaning they are already. Okay, that is some nice noise. Complete triangle BCD is congruent to triangle. You tell me. We are told, guys, that the diagram does consist of two congruent triangles. Now, what I need to find from you, if they are saying triangle BCD, look at these symbols. The three horizontal lines are symbols that stand for congruent. So you give me the order. In the comment section, Oyatando is saying ABD, Zazukola is saying A and D, Charlene is saying ABD. Thank you, Charlene. Luvian is saying ABD. Atita is saying ABD. Zazukola is saying ABD. Luvian is saying ABD again. Black Crew Young Stars is saying ABD. And my good friend there, the girl from Stellies who spams with KK. Oh, that's why. See. So the girl from Stellies is spamming with KK. That's why you keep on typing perimeter and area. Do perimeter and area. You're spamming me there. Okay. I'm on top. ABD, Mashot, then ABD. So let's look at BCD. Triangle BCD. The love for you is saying, how is it congruent? Love for you, look. Read the statement. The diagram consists of two congruent triangles. They are telling us it's like that. The diagram consists of two congruent triangles, and all that they are asking us now to do here is complete. So if they are saying the diagram does consist of two congruent triangles, it's finished. The triangles are congruent. Okay, in other words, there are two triangles that are exactly the same shape, same size. They are exactly identical. That's what they are saying. So triangle BCD, this is the order. BCD is congruent to what? Triangle. It has to be then BAD. Please, guys, move in the same direction and order. If it's BCD, then we move in the same direction and order. BAD. It's bad. It's bad. It's bad. It's bad. It's bad. Some people are saying like, yo, paper 2 is bad. You know, I can imagine. Some people are saying paper 2 is so bad. You know, or I'm bad at this, I'm bad at that. Have you ever heard those people that always go on and on and on about how bad they are? You know, sometimes I just wish to say to them, just shut up. You know, telling me that, yeah. Luvian, please, my leader, put things in the order. Okay, Luvian, I am very strict with my learners. My learners, I tell them, if they say ABD to me, they are wrong. I tell them that. Okay, I tell my learners in my school, and this is just to sort of like inculcate in their heads the order. Because remember, what did we say congruent is? Congruent triangle. It means same shape, same size, exactly the same. So when you put the order of your letters, okay, you should be able to then say, okay, which angles? Okay, look at this. Angles that are equal. Luvian, when you look at the order of your letters, you should be able to say this B is equal to that B. In other words, the B of this triangle, okay, is equal to the B of the other triangle. Now, if you look at the two triangles, is that actually true? Okay, what is BCD? BCD. So BCD specifically, we are talking about B2. So in other words, angle B2 of triangle BCD is equal to what? To angle B1 of triangle BAD. First is equal to first, and look at them, they are both equal to what? To x. Okay, so I can write that down. B2 is equal to B1. Okay, it is. It's like that. It's fact. It's fact. It's there, right? And it's also in the fact that I have been told the diagram consists of two congruent triangles. So from the get-go, I identify those two congruent triangles and I say they are congruent, but the order is important. So for me, when I speak to my learners, maybe for a different teacher, I don't know, but for me, guys, when I speak to my learners, I'm like, no, guys, please make sure when you write your letters, you make sure you write them in the correct order, please. The first letter will be equal to the first letter. Look at the second letter. Angle C is equal to angle A. Angle C is equal to angle A. I can write that down. Angle C is equal to angle A. Now, some of you are going to be like, but sir, what's the reason? Dude, we were told the diagram consists of two congruent triangles. Write them. They said complete, so just complete. I completed that BCD is congruent to triangle BAD. Now, which angles are equal? Like I said, because I've written things in the right order, angle B2 is equal to angle B1, which is equal to x. Angle C is equal to angle A. If you look at A, here it is. C, there it is. Okay? It should actually just work out because we are told that the two triangles are congruent. We are told that they are. Then the last statement, which other angles are equal? It should then stand that this D is equal to this D. For this D, which D is it? It is angle D2. And then for the other triangle, which D is it? It is angle D1. Okay, so angles that are equal, here they are. 1, 2, 3. Let's finish off. Sides that are equal. Which sides are equal? Well, smell the roses. If you look at the order of what I have here, okay, BC should be equal to BA if you look at the order. Okay, let's look at BC. Here's BC. Look at BA. There is BA. Is BC actually equal to BA? Yes. BC is equal to BA. All right. Last two should also be equal. In other words, CD should be equal to AD. Where's CD? CD is equal to AD. Okay, guys, this is the beauty of making sure that the order of the letters is correct. BC is equal to AD. BC, CD, my bad, is equal to AD. CD should be equal to AD because we were told that the diagram consists of two congruent triangles. It's in the statement. The fact that they are congruent means that the angles are equal that are corresponding and the sides are also equal that are corresponding. Does the order of the letter matter? To me, it does. Okay, I repeat, to me, to this teacher, the one who has Maths is a Game as a platform where he's teaching hundreds of learners every single day, to me it's important. Okay, and through years of experience, guys, of having been in the field and the profession, I've concluded that the order of the letter matters. So BC is equal to BA because I've made sure the order is correct. BC is equal to BA. CD is equal to AD. CD is equal to AD. Okay, and then lastly, first and last, BD is equal to BD. Now some of you are like, BD for this triangle is equal to BD for this triangle. This is a common side for both triangles. So BD is a common side. Hence we say BD for one triangle is equal to BD for the other triangle. They share that side. It's a common side. I've written all the angles that are equal and all the sides that are equal when the two triangles are said to be congruent. The two triangles, as it says, the diagram consists of two congruent triangles. Okay, the diagram consists of two congruent triangles. So because the triangles are congruent, it stands to reason that the corresponding angles of each respective triangle will be equal, and the corresponding sides, okay, first, last two, first and last, the sides are equal, the angles are equal, because we were told that the triangles from the beginning are actually congruent, and there are two that are consisting, that are congruent. Does order matter? You tell me. Order does matter. Okay. Order does matter. Okay, let's wrap it up, guys. Let's wrap it up. I know some people are like, it's past my bedtime. I need to sleep. Okay, guys, remember that sometimes the reason why people get lost is because you'll find maybe in school the foundation, okay, because remember, I'm just here to revise. So you'll find that maybe the concept even at school was not taught, or not taught well, or you were not really paying attention when you were at school. You didn't really care, or you were minding your own business. You know how it is in school, man. You have your friends, you're chilling, having a good time, the aura is auraing and all of that stuff, and people don't really pay much attention, and it bites us. It comes back to bite us very hard, especially at the end of the year, when we feel like we're just so sick and tired of school. We just want to go on holiday. Christmas is coming, like we're just thinking of Christmas clothes and all of that stuff. Then we miss this, and then we write the exams, and some of the things are just over our head. Okay. Yeah. You see, the confessions are coming. No, I didn't understand. I was lost completely. You see, that's the thing. But you see, you didn't raise it up with your teacher and say, sir, I don't understand. And or go the extra mile and go and ask the questions. Anyways, let's do this last question. The sketch below shows the dimensions of Stella's garden. Ooh, look at Stella, guys. Stella's beautiful garden. She needs to fence the garden in order to keep the dogs safe. Who let the dogs out? Who? Okay, sorry guys. The sketch below shows the dimensions of Stella's garden. She needs to fence the garden in order to keep the dogs safe. So this is basically the fence. Okay. AB, 12.5 meters. BD is 5.5. CD, you can see, and then AD. But we have what here, guys? We have parallel lines. This line parallel to that one. This side is parallel to that one. First question, what type of quadrilateral is represented here? What type of quadrilateral is represented here? In the comment section, people are answering very beautifully. Yes, guys, it is indeed a what that we have here. A parallelogram. And maybe you're going to ask why. Thing is, we can see that both sides are parallel. Both pairs of opposite sides are what? Are parallel. Both pairs of opposite sides are parallel. That's why we say it's a parallelogram. This side is parallel to that one. That side is parallel to that one. Okay? That side is parallel to that one. That side is parallel to that one. And the reason why we say it's not a rhombus, it's because you can see this AB horizontal dimension is not equal to its adjacent side. Okay, if these adjacent sides were equal, then we would say it's a rhombus. But these adjacent sides are not equal, guys. Okay, but both pairs of opposite sides are parallel. So this is definitely going to be a what? A parallelogram, not a rhombus. Next question, calculate the perimeter of the shape above. Since we've established it's a palm, then of course this side is 12,5, and then that side is also 5,5, because the opposite sides of a parallelogram are not only parallel, but they are equal. Both pairs of opposite sides are what? Are equal. So what do we do when we are calculating perimeter? We calculate the total distance. Imagine this guy was running around Stella's garden, starts here, runs 12,5. 12,5 meters, okay? Then runs an additional what? 5,5 meters. Then does what? Runs an additional what? 12,5 meters. Then runs back to where he started. An additional what? 5,5 meters. That's what perimeter is. Peri means outside. That's a prefix that means outside, and meter means distance. So it's the outside distance of the two-dimensional shape. So we add those together, okay, and we write the answer as you have said, which is 36 what? Meters. You guys are 100% correct. That is perimeter for the parallelogram. Okay, you guys are too smart. Danny, you are too smart. Okay, very, very smart. When can we expect grade 9 paper 1 lives? I'll do a grade 9 paper 1 live after I'm done with this. You want to take it up until 12 o'clock? We can sleep at 12. All right, we can sleep at 12. I'll finish off this now in 4 minutes, and then we'll start up the grade 9 live, and we'll do a paper 1 with grade 9. What do you think? Think that's cool? All right. The fencing only comes in 12-meter rolls. Which fencing? That fencing. It comes in 12-meter rolls at 150 rand per roll. Okay. The fencing only comes in 12-meter rolls at 150 per roll. Do you see that, guys? Fencing only comes in 12-meter rolls at 150 per roll. How much would she pay to purchase the fencing? I will have this on my YouTube, guys, when I'm done. Okay, I'll try and download the video ASAP so that I can upload it onto the YouTube channel, so you can watch it there. I've done many other papers, guys. Paper 1 grade 9, it's there in the YouTube channel. Paper 2 grade 9, there in the YouTube channel. You can check out my link in the bio. Link is in my bio, guys, for the YouTube channel. You just copy the link, the YouTube link, you paste it onto the Google search engine, you press search, you go to the YouTube channel, you subscribe. Please hit the notification bell, so that when you get when I upload things there, you can get a notification that whatever is uploaded, and then you can hop on there. Grade 11 is also there, guys. Especially if you are in grade 11, you're writing paper 1, then you can check it out there. Yeah. How much would she pay? Thank you, Bram Fana. How much would she pay to purchase the fencing for the garden? So what do we do here? Okay, we know that Stella has 36 meters of fencing. Now the fencing is coming in 12-meter rolls at 150 per roll. So for every 12 meters you pay 150. 24 meters you pay 300. 36 meters you get the point. All right. Fencing only comes in 12 meters. All right, so we need to take the perimeter of the fencing for Stella, which is 36, and we can divide that by the 12 meters, okay, which basically gives us 3. All right, take that 36 meters divided by the 12-meter rolls, we get 3. So that means we can buy 3 of these 12-meter rolls, 3 of them. All right, so 150 each. So that therefore means the total price of those rolls that we are going to have to buy is going to be 3 times the 150 rand. And as you guys have beautifully said, this will be 450 rand that I'll be paying. Okay, so yeah, I guess I need 3 12-meter rolls. That's what I need. Okay, since the perimeter is 36 divided by 12, that means I need 3 12-meter rolls. That's what I need. Okay, then for those 3 12-meter rolls, for each roll, remember, okay, that I get of 12 meters, I pay 150, so that means 150 times 3 will give me 450. So I'm paying 450 as a total amount so that I can fence, so that Stella can fence his beautiful garden. Okay, now to my grade 8s. Okay, there was another 2023 paper that I had here. I'm not going to do it. I had previously done this. This is actually, you can find this grade 8 2023 paper. It's one of the videos that's already on my YouTube channel. You can find it. I did it 11 months ago, more than 11 months ago. You go to the playlist for grade 8 maths paper 2. All right, but look at this. The sum of angles of a triangle is equal to, are you kidding me, guys? So simple. That is C 180. Why is A and B equal in the diagram? Look at A and B. Look at the relationship of A and B. You have parallel lines. Why are those two equal? Is it alternate angles corresponding or vertically opposite angles? Guys, surely you can see the answer. It's so evident. It's in your face, right? Name of the three angles in this type of triangle are the same. None of the three angles in this type of triangle are the same. Is it an isosceles, where you have no side that is equal to the other? Is it an equilateral? Is it a scalene? You're welcome, Sylvie boy. You're welcome. All right, I really appreciate that magnitude of gratitude there in the comment section. Okay, it means a lot. It makes it worthwhile to go live when I am able to see such. And thank you for those that were able to generously send heart me's, what you may call. I saw a donut come through from Yegeni at some point. Yeah, we had a few gifts. Thank you so much. I really appreciate those when they do come. Thank you so much. You're welcome, Luvian. You guys have been phenomenal. Some of you are so good. Yeah, some of you I know are just gonna get 100%, the 90s, 95% for maths. Hopefully, guys, you can also, if you guys are interested, I'm actually going to be having a holiday starting on the 15th of December. I know some of you are just gonna be holidaying it up and are going to be like relaxed and you don't want any maths, no school. But I'll be having a holiday sort of like pre-program for grade 9s that are planning to do grade 10 mathematics, pure maths in grade 10 next year. So starting on the 15th of December, okay, you can inbox me about like the details and stuff and how it's going to be going about. I already have a few people that have actually said they want to do this with me, and they have already indicated, they've told their parents. What's important for me is for you to alert or tell your parent that on the 15th of December, there's this guy who wants to do online live lessons with us. He'll be having us as guests on the live lesson. You see that I did not accept any of your requests. I don't accept requests except, of course, those are individuals that I am working very much personally with. So like people, like I said, who become part and parcel of the journey with me throughout the year and who are able to see the fruits of basically being guided by me throughout the year. So those people who are interested in the early preparation for grade 10 maths, so that when you start the year next year, you start off on a bang. Level 7 distinction, beginning of the year, 90 and above throughout the year next year, so that maths doesn't become a challenge. Whether your teacher teaches you or not, whether he comes into the class or not, you are covered, you are sorted, your distinction is secured. You can just, like I said, inbox me, send me a message, but please do speak to your parent first. Let them know. I will give you the details to everything when you indicate to me in the inbox that you would like to be part and parcel of what I want to do. So you need to first and foremost tell your parent, go to your parent first and say, mom, dad, auntie, grandpa, foster home parent, whatever it is, whoever it is who's your guardian, let them know that you were on my platform today. I was doing some grade 8 revision, you're writing tomorrow. You can tell them the truth. It was a horrendous experience, hated every moment. The guy can't explain maths to save his life. He has stinky armpits. And then what you can do is let them know. And if they find my armpits quite stinky and they want to be part and parcel of this, then they can come and join. You can actually come and join. Like I said, I'll share the rest of the details, the cost and all of those things. And then I'll add you guys onto a particular WhatsApp group. You'll be a group, and there are certain things that will come as perks with that, and we can just make sure that by the time things start next year, your maths is mathsing. We don't have a challenge with maths. You are going to have the chance to focus on the subjects that are a struggle, but maths will not be one of them. And that is the point. Getting the marks that you deserve will be something that will be a reality, but because we'll be working on that. So if you are interested in something like that as a grade 8 learner who's going to grade 9, or as a grade 9 learner going to grade 10, especially the grade 9s who are going to grade 10, let me know. But if you're a grade 8 learner, you still want help next year, grade 9 next year, please also let me know. There's that program that I'll be starting, like I said, that time. Okay, sorry Spusi, so that you're running out of data. I'm sorry. Thank you so much anyways. Okay, grade 11 I'll also be doing in December. Okay, and I have beautiful testimonies. Grade 11s, they have really been, it's been good, right? Grade 11. So yeah, guys, this is the other paper. Just check it out. There it is. Determine the length of EF. This was 2023. All right. Perimeter style stuff. Determine triangle XYZ, where XY is equal to 5, XZ is equal to 3. Which angle is the biggest? Very interesting, guys, that whenever you have the side that is the biggest will have the angle that is the biggest. That is something that you need to understand about a triangle. In any triangle, the longest side will have the biggest angle, right? So it cannot, if you have triangle XYZ, where XY we are told is 5, XZ is 3, and YZ is 3. Which angle is the biggest? So obviously the angle that will be the biggest will be angle Z. Okay, angle Z will be the biggest because it's opposite the biggest side. So the biggest side will have the biggest angle, and that's very important. Okay. Lines intersect each other at right angles. These lines intersect each other at right angles. Which are they? Definitely perpendicular. Which triangle is congruent to the given triangle? Guys, congruency of triangles has to do with what? Same shape, same size. Okay. For triangles, guys, when those triangles are exactly the same, exactly identical. So this triangle, is it exactly the same as A? Definitely not. Is it exactly the same as B? Definitely not. Is it exactly the same as C? Yes, you can see, guys, look, exactly. You see? And exactly. Side, angle, side. This is SAS, side, angle, side. That is the exact sameness of those two triangles. Page 4. There's page 4. Which of the following is a property of a kite? 2 pairs of adjacent sides equal. Opposite sides equal. Opposite sides are parallel. Obviously, guys, 2 pairs of adjacent sides equal. Calculate x in the given diagram. Guys, you can see this is straight line. They share a common vertex. This angle, that angle should give you what? 180, guys. 180. So x definitely equal to what? To 30. Okay, because 90 plus 60 is 150. Plus what gives you 180? It's 30. Okay. Oh, guys, terminology. What? A transversal or diagonal is any straight line that intersects a pair of straight lines. What is it? Any straight line that intersects a pair of straight lines. It's a transversal. 2 angles add up to 180. They are complementary or supplementary. Obviously, scalene triangle has no equal sides. Point at which 2 straight lines meet to form an angle. We call that a vertex. Has 4 equal sides and only opposite angles are equal. And only opposite angles are equal. It's not a square, but it's a rhombus. Okay. Yeah. Okay, then geometry of straight lines. Identify angles A and B. What type of angle is that? Obviously, it's obtuse. What type of angle is that? It is reflex. Then here we are told to consider the diagram below and complete the table. Example 1 and 2 equal to 180. What are those? Co-interior angles. Okay. Parallel lines. 3 is equal to 6. 3 is equal to 6. These are what? These are vertically opposite angles. Corresponding angles, parallel lines, which are corresponding angles, we have 1 and 6 that is corresponding bottom of these parallel line on the same side of the transversal line. We have 2 and 4, those are also corresponding top. We have 6 and 8 top. We have 5 and 7 bottom. You see, have so many angles here that are corresponding. And then alternate, we have 5 and 2, that's the Z shape. 5 and 2 are alternate. We have 3 and 8, that's alternate. We have 7 and 4, that is also alternate. And then we have 1 and 3, that's also alternate. You see, so we have 1 and 3 alternate, 5 and 2 alternate, 7 and 4 alternate, 3 and 8 alternate. You see, alternate angles galore, guys. So this is very important, being able to identify pair of angles in a diagram that is given to us. Find the value of x and give reasons for your answer. Guys, you can see most statement and reason. Okay, 3x is equal to 33. You can see most. What's the reason? Vertical angles equal. You solve for x, no problem. Solve for x here. We have 90. We have 2x. We have 3x plus 1. These are angles on a what? Straight line. So we can add these three if we want to get the answer. Add up to 180. Give the reason. Angles on a straight line and solve for x. Not a problem. Hi guys, this is so nice. It's like it's cool maths here. Study the diagram below for triangles and answer the questions that follow. Determine the values of A. Okay, there's 72 here. There's A. You can see more. Z shape. A and 72. Okay. A and 72. Alt angles. RS is parallel to TU. Straightforward. Then when you have 72, you update the diagram. Look at this triangle, guys. B, 90 and 72. You just add these angles in a triangle if you want to get the value of B. Not a problem. B, 72 plus 90 is equal to 180. Sum of angles in a triangle. You get the answer. Straightforward. You get 18 degrees. Not a problem. Okay? Very straightforward. Very straightforward to the point. Turn over the page. Hey, we have exterior. Okay, look at this. What type of triangle? Isosceles triangle. What do we know about these sides? They are equal. Find x. Here is x. So what can we do here? We know that is 63. So that is also what? That is also 63. Why? Angles opposite equal sides. Let's not forget that reason. Then after that, we can take this 63 and this x. These are sharing a common vertex. 63 plus x will give us 180. You can say x plus 63 is equal to 180. Angles on a straight line. So for x, that's very straightforward. Define the term congruency and give one condition of congruency. So the term congruency means exactly the same shape according to the sides and the angles. Exactly the same shape. According to what? According to the sides and the angles. Then here are some of the conditions. You have SSS, you have SAS, you have RHS, and you have AAS. That depends on the type of congruency case that you have. And look at this one. They say ABC and XYZ are congruent. Show with reasons why this statement is correct. Okay, so they were told they are congruent. So we need to show with reasons why this statement is correct. So you can see, guys, that AB is equal to XY. Okay, that is given to us. They are both equal to 2 centimeters. AC is equal to ZY. Okay, both of them are 3 centimeters. Right, and then lastly, angle A is equal to angle Y. Angle A is equal to angle Y. That's an angle. So that means the two triangles are congruent, and that is the case of congruency. SAS. Okay, so how they know which one to start with? What do you mean? How do you know which one to start with? Like which one to start with, as in what side or angle to start with, you mean? Oh, like the angles on the sides. You just compare the two triangles first. Just look at the two triangles and compare and look at what you see. So for instance here, you can see AB is 2 centimeters. This one, XY, is also 2 centimeters. So that means AB is equal to XY. That's for sure. And you can see it's 2 centimeters. That's actually literally given to you. Okay, that's something that's given to you. And that's a side, right? That's a pair of sides that are equal. Then angle A is equal to angle Y. All right, angle A is equal to angle Y. That's 29 degrees. That's also what? That's solidly given to you. Okay, that's an angle. And then lastly, AC is equal to ZY. That's 3 centimeters. That's also a side given to you. Now, from what I have, it's a side that I have, it's an angle that I got, and there's an S that I have there, another side. So that's why I usually write the letters here along the 3 statements, so that at the end, remember here they said, what are the conditions? Give one condition of congruency for triangles. Guys, there's side, side, side. That's when you identify 3 pairs of sides being equal. There's side, angle, side, all right? And there's also right angled, hypotenuse side, and angle side. These are 4 different cases which help you prove what? Congruency. So here in this case, side, angle, side is the case of congruency that is relevant. Now, when you write your triangles that are congruent, remember what I said. The order, I said the order really matters, right? So if you're going to say A, B, C, remember you are moving from 2 to nothing to 3. So you do the same thing here. You move from 2 to nothing to 3. So when you write your letters here, I think I actually didn't write the order correctly here when I did this. It's, if you say ABC, you're going to say triangle ABC, then you can say it's congruent. Now, congruent to what? You said 2 to nothing to 3. So do the same thing here. 2 to nothing to 3. That means Y, X, Z. Y, X, Z. Does that make sense? If you say BAC, then of course, as you've said, my pal, if you say BAC, if you say triangle BAC, then you are going to say BAC is congruent. You see, you move from BAC, that is 3, 2, 3, nothing. So you are going to move 2, 3, nothing, X, Y, Z. Then you can say triangle X, Y, Z if you say BAC. Okay, and then you can say side, angle, side as your case of congruency. So just always move in that direction. I hope you understand what I mean by that. Okay, I think the concluding questions here. Then we had a triangle, ABCD is a parallelogram. Prove that ABD and BCD are congruent. ABD is congruent to what? BCD. So here you can see, what do I have? A parallelogram. What do I know about a parallelogram? I know instinctively. I don't need to even be told. I know the opposite sides of a parallelogram are equal. So what I'm going to say is, first and foremost, BD is equal to BD. This is a common side, right? That's my first S. AB is equal to DC. AB is equal to DC. What's the reason? Opposite sides of a palm. Opposite sides of a palm. That's a property that I know about a parallelogram. AB is equal to DC. My reason? Opposite sides of a palm. That's my second S. Then lastly, AD is equal to BC. Why? Opposite sides of a palm. That's my third S. So now what do I have here? SSS is my case of congruency. Then I conclude. Triangle ABD. ABD is congruent to triangle BCD. Now, remember, I'm going to force the situation that I write the letters in the order. Now, when I look at this, I'm like, okay. Guys, I did this live last year, and I can tell you this. I wasn't that much, I wasn't that much alert last year when I taught this about the order of the letters, but then I learned my lesson, and then I emphasized this thing over and over again about the order of the letters. So if I'm saying ABD, Okay, let me be mindful of where I'm moving. I'm moving from the parallel line to the empty, to the two parallel lines. So I should do the same thing here. Okay, C, D, B. If I'm saying A, B, D, then I should also say here C, D, B. So if I'm going to say triangle A, B, D, then I need to say it's congruent to what? C, D, B. C, D, B. And then I write S, S, S as my case of congruency. I hope that makes sense to you guys. Y, A, B, D. Remember, from 1 to empty to 2. So same thing here. From 1 to empty to 2. So I'm going to say A, B, D. And I'm going to say here C, D, B. Okay, for my order of the letters. I don't think your teachers will be particularly concerned about the order of the letters. To be honest, your teachers probably will not. But I tell you this one thing, if I was the one teaching you, I probably would be, and if I was the one marking you, I'd be very petty about the order of the letters. Okay, but that's just me. That's just me. Okay. At the end of the day, it's the two triangles. They are congruent. She said, I would love to see that visible in the letters that you have there as well. Okay, then Pythagoras is the one here that features. You see, complete the theorem. In a right angle triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. Okay, does that make sense? Yeah, that is the theorem of Pythagoras. Now you see, it was a matter of filling in the letters. Then show all calculations, find x and y. So once again, you're looking at the triangle here, the big triangle, but the big triangle has how many triangles inside? 2. You want x, but you look at this triangle if you want x. You want y, you look at this right angle triangle to find y. This right angle triangle is missing x, which is a hypotenuse. So it's straightforward hypotenuse substitution. The square of the hypotenuse, you say x squared is equal to 16 squared plus 12 squared, hypotenuse, Pythagoras, and then you solve for x. Okay, this one also, you have 12, you have 15, you have y, you have enough information for this right angle triangle, so you do the same thing. The square of the hypotenuse, which is 15, you say 15 squared is equal to 12 squared plus y squared. Take the 12 squared over to the 15, 15 squared minus 12 squared is equal to y squared, and then you calculate the value of y by taking the square root on both sides, and you get y is equal to 9, whereas you get x is equal to 20 units. Okay, you can do that calculation. You can do that on your own at your own time. Just want to show the others. Then we had quadrilaterals. So they are dealing with your kites, your properties, you know, find the values of A. Very straightforward, guys. What is the value of A? Obviously, A is 4 centimeters, adjacent sides of a kite. Then B, what is B? B is equal to 9 centimeters, adjacent sides of a kite. Very straightforward, guys. Okay, this paper from 2023. Find the size of the angle with reasons. Look at this one, quadrilateral. Thank you so much, Bandele Boy, for the rows. Got 80 degrees, 50, we've got x, we've got 70. All we need to do here is we add all 4 angles, equate to 360, we write the reason, sum of angles in a quad, solve for x, we are happy in the bank. So this paper was quite straightforward. Okay, 2024 for this district compared to 2023 for this district. These were 2 nice papers. Okay, yeah. All right, guys, thank you so much. I think that pretty much wraps it up for our beloved grade 8s. You guys have been great sports. Thank you so much for being here. It was really good. I really enjoyed our time together. And yeah, so this was basically the paper that I've just done with you from the beginning. Thank you so much, and I hope you guys have a good one. Cheerio, tootles, grade 8s. Thank you so much for joining. It was good. It was good. Okay, paper 2.